Okay, now the next question. The question is prove that this determinant is equals to 2 into a into b into c into a plus b plus c whole cube. Okay. Now the terms inside the determinant, I am reading it. First row, b plus c whole square, b square, c plus a whole square, b square, c square, a plus b whole square. Now see how. Now doing this question has a very important role in like understanding the whole determinant in a new way. Now wherever you have written the notes, steps to think, okay, the thinking process, there you will add whatever I am saying right now. Okay. Now see while explaining the determinant at the end of the video, when I was discussing the steps, I told you later I will say you something which will make the things a little bit easy, where you don't have to go exactly like steps. Okay. Now listen very carefully and please write down at the end of the theory this thing. Okay, whatever I am about to say is that, for example, we have a prove that question. Okay, they saying using property prove that. Like one, using property prove that, or simply they ask you prove that. What I have told you, my job is to make 1 1 1, then 2 zeros in any one row or any one column, and then you expand. While expanding, we see to take out common or not, to make it simpler, right? Taking out common is the only way, aim is that to make the expansion simpler. Okay. Now, for example, any student don't understand these things. Okay. For boards, especially for boards, I'm telling you, not for practice. Okay. For practice, you will follow the protocol what I've told you. For boards, you don't understand anything. Okay. Then we have one basic rule. What is that basic rule? Is that in the whole determinant, okay, if you don't understand, if you cannot make in any one row or in any one column 2 zeros, you cannot make, then what do you do? Every question, okay, any question you're dealing with in type 1, under type 1, your job is, listen carefully, make 2 zeros anywhere in the whole determinant, okay, simplify the rest of the terms and then you expand. Okay, this is the job. The overall job, the main aim of doing any question under type 1, using properties prove that under type 1, your job is to make 2 zeros in any way in the whole determinant. Not in any one row. It's not mandatory that you should have 2 zeros in any one row or any one column. No, it's not necessary. Okay, you can make 2 zeros anywhere in the whole determinant and then you simplify the rest of the terms using the properties, using the operations we studied, okay, and then you expand the determinant. Okay, so this question I will do it in that way. Okay, like because this question we cannot do step 1 and step 2, it's not possible. So if any question we can do step 1 and step 2, like in the previous questions, whatever we did in the previous videos, we try to make 1 1 1. We make 2 zeros in any one row and one column, then we expand. What do? You do at your home, like you start the question. You make 2 zeros anywhere in the whole determinant. Okay, simplify the rest of the terms and you get the answer. That is also correct. You will get full marks, 4 out of 4. You understand what I'm saying? So overall concept that if any question or if you don't understand anything, what's your job is, you make 2 zeros anywhere in the whole determinant. Okay, and then you simplify the rest of the terms. Better if you simplify. If you don't simplify, if you directly expand, you will get such a huge thing that you won't be able to get the answer only. Okay, and in boards, how the checking is done. Okay, when you're making 2 zeros anywhere in the whole determinant, as soon as you did this much, out of 4, you already got 2.5 marks. Okay, you already got more than 50% of the marks. Okay, so let's deal with the question right now. So please, again, I'm saying one more. Please write down these things in a notebook. Which part you will write? Like you will write like this, at the end of the step to thinking, a special note. In any question under type 1 sum, you write like this. In any question under type 1 sum, okay, you have to make 2 zeros anywhere in the whole determinant, those zero lana, and then simplify the rest of the terms and then expand. Okay, now see, this is the question. I am writing the LHS. Now, for example, right now I am not doing the boards, so I will think according to protocol. The protocol say take out something common from rows and columns. From the row, getting common a square here. I'm not getting a square here. B square here. I'm not getting b square here. I'm getting c square. Here I'm not getting c square. Okay. Common is not done. Similarly, if I add all of them, all are different terms. B square, b plus c whole square plus b square plus c square. A square plus this plus this. The terms will be different. Adding also it will not help you. So these things you can try. Okay. So this question, what I am doing, I can see directly a square के ठीक साइड में a square है, b square के ठीक साइड में b square है, c square के ठीक साइड में bc square है. So what I will do here, I will make two zeros directly. Okay, because here 1 1 1 not possible. Understood? When you start solving more and more questions, then you will also try to you will automatically will understand that yeah, this question we cannot make 1 1 1. This question we can try. We cannot make two zeros in any one row or column. We have to make two zeros anywhere in the whole determinant. Okay. From the determinant only I can see a square, b square, b square, b square, c square, c square. Okay. So what I will do, I will try to make two zeros. Okay. Now how to make? You have a square. अब क्या करोगे? Try to understand what I'm saying. You have a square. इसके साइड में देखो और इसके नीचे देखो. कहाँ सिमिलर टर्म दिख रहा है आपको? a स्क्वायर के इस साइड में a स्क्वायर दिख रहा है. You understand what I'm saying? इसके साइड में दिख रहा है. Similarly, so knowing these things, this video will be long, because lots of things you need to understand here. Okay. Now similarly, इस b स्क्वायर के ऊपर देखो, नीचे देखो और साइड में देखो. तो what I am saying is that you have an element, उसके ऊपर नीचे देखो, उसके साइड में देखो. You don't have to see the whole determinant. Where you can see the like terms, that's the job is. Okay. So I can see a square के साइड में a square. This side, left hand side, exactly down. Not anywhere randomly. You cannot see crosswise like this. Okay. You have to see either left, right, up, down. Right, left, up, down. You have to see like this. Okay. So I can see here a square. So R2 minus R1. R2 minus R1. Now see, here we make a mistake. I am subtracting this minus this. Are these rows or columns? They are columns. So it is C2 minus C1. C1 or C3? What I am subtracting? C2 minus C3. Okay. Subtracting C2 changes to C2 minus C3. So I am getting 0 here automatically. Understand? Plus, similarly, next thing is see here. B square. Here B square है ठीक इसके साइड में है B square. See, I can see B square. Understood class? What I'm saying? So what I'm doing? I'm doing C1 changes to C1 minus C3. B square minus B square. You will get 0 here. You understand what I'm saying class? Okay. Now, you do one by one. What I did two steps together. You make one for 0, then another. Okay. In first step you do like this, second step you do like this. Now, while you're making zeros, what I do, I can do it like this also. Instead of C1 minus C3, instead of this, I can make C3 change to C3 minus C1. ऐसे भी तो कर सकता हूँ, isn't it? C3 minus C1. That will also give me 0 here. This step will give me 0 here because I'm changing C1, and this step will give me 0 here because I'm changing C3. Now the question is, which one to follow? This and out of these two, anyone you can follow. Both are operation wise correct. Okay, but what will happen now? At the end, when you start solving it, you will, while expanding it, becomes very tough. So in theory, I have told you, try to make these things same. Make one column or one row fixed, and then you subtract the others, right? Remember? So what I will do, I will make C3 common, and then I will try to C2 minus C3, C1 minus C3. C2 minus C3 will make 0 here. C1 minus C3 will give me 0 here. Okay, understood? Now, what I have taught you here, a very important part is that when you are doing some properties, any one column make it fixed, and the rest two you subtract it. Okay, but if you do it in this way also, see, here C2 minus C3, here C3 minus C1. These two are not same. Nah? We can do this thing also. Property wise, operation wise, both are correct. But at the end you will face a problem. Okay, so what I am trying to say, you understand? If you don't understand, repeat the video and again listen carefully. Okay, now what I have shown here is different from what I did here. Okay, what I am trying to say is that do it in this way. When you start practicing at home, do it in these two ways. Okay, now what I did here, I showed you make C3 same. What I did, I made C1 constant. I have taken C1. Okay, I have taken C1 and we try to subtract the C2 and C3. See CC. Beside it we have C3, C2, C square. C square and C square will give me 0. Okay, so I am fixing the C1 here. I am subtracting C2 minus C1, C3 minus C1. B square and B square. Okay, so I am making C1, C1 same. Constant here. Okay, I am fixing C1 here and I am subtracting the other two columns. You understand, class? So I am doing different from what I have explained to you right now here. I want you guys to do the same question, do it in this way. Okay, here also see minus part. The minus part is same in both the cases. Okay, so let's subtract. So what I am changing? I am changing C2 and C3. So I am not changing C1. First I will write the C1 here. Okay, now C1 I am not changing. I am changing C2. C2 minus C1. A square minus this. This minus this. C square minus C square. Okay, now next I am changing C3. How I am changing? C3 minus C1. This minus this. Here. This minus this. 0. This minus this. Here. Okay. Now, after doing this, we got two zeros in there. We got two zeros. Now, don't think like that. Sir told, make two zeros and expand. No, sir said, make two zeros, try to simplify the terms and then you expand. Now we'll go for simplification. Okay, we made two zeros. Now again search for common terms. Because see here what we have in the RHS. A, B, C, A plus C whole cube. Things will come out common. So, can you see how we can get A plus C from here? Okay. Now, the mistake what you do, you try to open B plus C whole square. If you try to open B plus C whole square, this will not give you A plus C. But if you open the formula A square minus B square. A square minus B square. Okay. So, I am writing this whole thing here. A square minus B square. A minus B. A plus B. I am getting A plus C. Again A square minus B square. A minus B. A plus B. See? I am getting A plus C. 0 will remain 0. Again A square minus B square. A minus B. A plus B. 0 will 0. A minus B. A plus B. Now, after opening the formula, what I can see? From C2, I am getting A plus C, A plus C common. From C3, I am getting A plus C, A plus C common. So, I am taking common A plus C from C2 and C3. So, we are taking common 2 times A plus B plus C. So, we will have whole square outside. One from C2, one from C3. So, I am not doing anything from C1. So, I am writing the C1 exactly the same way. Then from C2, what I have taken out common? A plus B plus C. So, what I left with? This term here and this term here. 0 will remain like this 0. Then again from C3, what I did? I have taken A plus B plus C common. So, I left with this term here, 0 here and this here. Okay. Now, we got A plus B plus C whole square also. Now, again, what we do? Again, we make a mistake. We try to expand. Again, no. Here, if I try to expand, so many terms, big terms, 3 terms, 3 terms, 3 terms, 3 terms. If you open this also give you 3 terms, B square plus C square plus 2BC. Okay, now we try to simplify it. You understand? Now, while simplifying, again, after making zeros, we will simplify in such a way that it should not disturb the 0, right? So, what I will do, I will deal with that row which don't have any 0 or that column which don't have any zeros. Now see, this row R1 don't have any zeros. That means I will change R1. R1 को कोशिश करूंगा R2 R3 के साथ प्लस और माइनस करने के लिए ताकि टर्म्स छोटा हो जाए. You understand, class? Okay. Similarly, which column don't have any zero? This column. C1 don't have any zero. So I will try to change C1. इनसे माइनस करके देख लूंगा. Okay. So now next question. Whether to work with columns or to work with rows. In the previous term we understand. Similar terms कहाँ पे है? Columns में है कि rows में है? तो columns में क्या है? B plus C whole square. B square C square है. Do we have B square C square here? No. That is working with columns. No use. The things will not cancel out. But if I work with rows, see b square c square, we have b square, we have c square. Understood? We have rows here. So I will work with rows. Now, you have to imagine b plus c whole square. If you open, what do you get? B square plus c square plus 2bc. Right? We have three terms here. ठीक उसके नीचे b स्क्वायर भी है, उसके नीचे c स्क्वायर भी है. दैट मींस इससे अगर मैं इससे इसको और इसको माइनस कर दूं, ओके, b plus c whole square minus b square minus c square, the things will cancel out. We left with only one term 2bc. So what I will do, r1 changes to r1 minus r2 minus r3. This minus this minus this, because this three term will convert into single term. Okay, because if you open this will give you three terms: b square c square plus 2bc. So if you subtract b square and b square, it will become cancel out. C square will cancel out. We left with only one term 2bc. Okay, and again see, I am changing only r1. That means these zeros will not disturb. So first, after making two zeros, see something is coming out common or not. If you are not getting common, we are applying the formula to take out common. Then don't expand. Try to simplify because so many terms are there. Okay. Now while simplifying, we have to change that row or that column which don't have any zeros. Okay, so we can see row 1 don't have any zero, column 1 don't have any zero. That means either we will change column 1 subtracting with the other columns, or we will change row 1 subtracting or adding with any one of the rows. Now, which one to work with, whether we deal with the rows or whether we deal with the columns. We will see like terms. कहाँ like terms है? क्या नीचे नीचे like terms है? अगर नीचे नीचे like terms होगा तो रो के साथ काम करेंगे, अगर साइड साइड like term होगा तो कॉलम के साथ काम करेंगे. You understand class? So here what we can see here, that नीचे नीचे below the terms we have similar terms. So I am working with rows. So see here, I mean which row I am working with? R1. That means R2 will remain same, R3 will remain same. So I am not dealing with anything. I am not doing anything with the R2 and R3. I am dealing with only R1. So R1 कैसे हो रहा है? R1 क्या है? B plus C whole square. R1 minus R2 minus R3. When you open it, what you will get? B square cancel, C square cancel. We left with 2BC. Okay, class. Now comes to this minus this, which I have shown here. A minus B minus C minus this minus C minus A plus B. Cancelling out, we left with 2C. Similarly, this minus this plus this minus this minus this. Again, I have shown here A minus B minus C minus 0 minus B plus C. Again, things are cancelling out, we are getting minus 2B. Okay? अब देखो तो कितना बड़ा help हो गया. We were having three terms here, we left with only one term. Three terms, one term. Three terms, one term. Such a huge load we decreased using this small operation. Okay? Now, can I see common 2 here? After doing this thing, we are again getting common 2, and we need 2 here also. So we are taking out common 2 from row 1. Rest everything will remain same. So what is left with? BC minus C minus B. Okay, class? Rest everything will remain same. Now we have to expand. Now again, in the theory times, when we are dealing with two zeros in same row or same column, then we try to expand with that row or that column which have two zeros, right? Here we are not dealing with that funda. We are making zeros anyway in the whole determinant. Then how to expand? Okay, so for better, we try to expand using that row which have zeros. Maybe 1, maybe 2. Okay, because see, if we try to expand by R1, we will have all the three terms to expand here. But if we try to expand by R3, this one term छोटा हो जाएगा थोड़ा. This term will become 0 totally. So we left with only one and this and this. Okay, so we try to expand by R3. In short, I want to say is that expand by that row or column which have zeros. You can expand by C3 also, no issue. Okay, you can expand by R2 also, no problem. You understand class? So I am expanding by R3. So plus C square, hide these two, what I left with, these four terms, I am writing it here. This 0 will 0, forget about it. Then this plus this, again hide this. Hide these two things, what I left with, minus BC plus C minus C, B square. Now you open it. C square will remain C square, this will this, 0, this will this. Again, this will remove 0, plus this will this will do this. Okay, now try to open it. C square minus into minus plus 0 plus B will be B into C square B. rest this thing I'm writing here. I'm not opening it right now. Why I'm not opening the whole thing? Because I may get something common here. What I get? I need 2abc also. I got 2a plus c whole square. Okay, so I'm just hoping that I may get something common. That is the reason I'm not expanding the whole thing. If after doing steps, if at the end also I'm not getting anything common, then I will open the whole thing. Okay, initially I will not open the whole thing like a Lego. So I'm keeping it in this way only. Again here, I'm opening the whole thing. See, BC minus into minus plus b square c. Again, I'm not opening because I can see common b square c bc. So bc will come out common from these two terms. BC will come common. So here I left with this term, here I left with only plus B. Okay, so try to take out common one by one, instead of labeling labor job. B will cancel out. Okay, now see this and this. Can we see common BC here again? So I'm taking out BC. So what I left with C here and this term. I left with this term and this term A plus C here. Okay, understood? Now at this step, जो भी कॉमन होना था आ गया. अब तो इस सबसे कुछ कॉमन नहीं आ सकता ना, कुछ कॉमन नहीं इन दोनों में से. Now I'm opening this thing, cancelling out. I left with a square, I left with ac, I left with ab. Again see, can you see common a? Take out common. I left with a plus b plus c. So 2abc into a plus b plus c whole cube. Understood class? So again I am saying one thing. Whenever you have written the notes, at the end you add up. Okay, type 1 questions, steps to think, wherever written, steps to think. At the end you add up. Whenever you face any type 1 sum and if you don't understand what to do, then you follow one protocol, that is, make 2 zeros anywhere in the whole determinant, try to simplify the rest of the terms and then expand by the row which have 0, okay, and you will get the answer. Okay, now one very important, we cannot expand without making 2 zeros. If the question is using property, you have to make 2 zeros anywhere in the whole determinant. If you fail to make 1, 1, 1, if you fail to make 2 zeros in any one row or one column. Okay.